Good afternoon everyone. So we've got a case here I thought I would record. It might turn out to be interesting. So we've got this Golf that's recovered in. When the customer phoned me, he said he had lights in the dash, it'd been somewhere else for a month. It seemed like a network issue from his description. But when he brought the car in, we wheeled it in at the front of the garage here, and it was low pressure codes and it was cranking and non-starting. So that's where I was at a while back. So I've done some So we had a vehicle come in yesterday. It had a very similar design fuel system. In fact, the fuel pump module on the car was the same part number. The fuel pump module is not at fault. I'll just tell you that at the moment. So this is the data. So I took the opportunity to retrieve some data using the picoscope. So the ECU controls the fuel pump module, which in turn controls the fuel pump. And we're looking at a duty cycle here. So this is the duty cycle at the pump, and this is the current consumption of the pump. So this would be a known good. So I'll just zoom in so we can have a look and see what that looks like, and I'll explain what's happening. Okay, so rather than give the pump full 12 volts the whole time and make it go full pelt, it's controlled by a duty cycle. So this is what we're looking at here. This is just the on-off control of it, so whether the voltage is there or not, it controls the speed of the pump. And at the moment, I'll zoom back out so we can get a better view of the current. So this is the current waveform here. So this is the pump running, and there's an amperage reading to that. So I'll just drag the cursor down. So we're right, that line right across, let me go down just a wee bit more, make it more accurate, just about there. You can see we're at 4.1, it's probably 4.1 to 4.5 amps of current draw. So this would be a known good. So that's what we're looking for on the car that we've got outside. We've got a low fuel pressure fault on the car outside. So the fuel pump is just your standard, fuel pump. There's one connector on it and one pipe, but it's a returnless system, so there's only one pipe out of the pump. So it's fairly simple to check. So this is what the pump looks like just inside. And there's a wee arrow there showing you where to land the kind of cap when you're putting it back down. So I'll go out to the car, we'll get the fault codes up, we'll show you what's there. In fact, no, I've probably created more fault codes. There's low fuel pressure fault codes there. So I'll show you what we're going to do next. Okay, so this is the car in question. This is the 1 litre petrol engine, the DLAA engine, if anybody that's interested in the type of engine it is. So this is the fuel supply from the tank, and it goes on to the side of the high pressure pump here. So we're looking at the high pressure pump, obviously the line going to the rail, and then the plug there for that. And this is, as I said, the low pressure supply. So we're interested in the low pressure supply at the moment. And I've got a can just cut open here, so I'm just going to put the line in there, like that. Try and get it sitting steady somewhere. Good. Right, like that. Okay, so we'll come back, we'll crank the engine, we'll come back and see if there's any fuel in our can. Right, so we'll crank it. You can hear it there, so crank, non-start confirmed. I'll just set the key down. Go back and see what anything in our can. Pretty confident there isn't, so I'm just going to treat it like this and pull it out. You can see the can's empty, there's nothing in there, so we don't have any low pressure supply, so that can rule out half of the system by concentrating on the low side. So I'll just connect that in, put my can out of the way, put that hose back on. I will connect the connectors back up at some point. Okay, we'll go to the back of the car now. So the low pressure pump sits behind the rear seat in here. I've already had this up. The module, this is the fuel pump module. Part number for anybody that's interested, that's upside down. There, fuel pump module's not the problem. I know that already. So we're going to do some electrical measurements at the pump. The reason why I'm showing you this is it's fairly interesting what I found. So I'll go and get the oscilloscope set up and I'll show you what's going on. Okay, so I've got the oscilloscope set up in the back of the car. We're using the Pico oscilloscope here to do our tests. I'm just going to walk you through my connections. So channel A, the blue channel, we've got coming in the black wire here, and this is the fuel pump module. For any of you guys that don't know, these fuel pumps are controlled by a separate module, and it just sits under the skin here. There's a kind of area in here, it slides in a wee housing thing in there. So this is the command. So this black wire, that's the duty cycle, that shows you the command from the engine control unit, and then in turn that controls the pump. So we're looking for control here, and then we're going to measure the pump current. So around this blue wire here, I've got the amp clamp set up. So that would be on channel C, which is my green channel, and I've set a trigger. So that little yellow diamond there's my trigger, so when this waveform passes that point it will start recording the screen. That way I can keep it in the middle and not go through half of the screen and make it messy and stuff. So we're going to set a single trigger, and it will keep that recording on the screen. We'll come back and look at it. So I'm going to attempt to start the car, so I'm just going to give it a crank. This should be enough for my waveform, so give it a crank. 2, 3, 4, 5 seconds and off. Okay, so we've got our waveform here, which is pretty nice. So we can see our blue there, that's just the resolution, that's like pulses, that's a duty cycle up here. Just because it's over a long period of time, it blends the colour together. So, and it's not familiar with oscilloscopes, that's what's going on there. And then we've got our amperage draw here. So if you remember at the start of the video, a known good amperage would be 4 amps. So I'm just going to pull that down over there. Okay, apologies for the noise, but I've put my cursor going across. You see that 14.5, so that's 14.5 amps, right where that line is, right across the middle of my current consumption of the pump. And there's the measurement there, 14.5. So it looks like the motor itself and the control of the pump is there. It looks like the motor inside the pump's healthy. I mean, it is drawing a lot of amps, probably about 3 times the amount that it should, or it should need to. So it looks as if there's some kind of restriction or mechanical blockage that's causing the amperage to be so high and not give us fuel. So the next thing that's left to do is there a blockage after the fuel line here, or is it in the tank? So the next thing to do is I'll remove my oscilloscope tools and take the pipe off. So it's a returnless system, you can see there's only one pipe on it. I'll pull that off. Okay, and I'm pretty confident there's no fuel going to come out of here. Alright, so I'll just quickly move this out of the way. I have done it with a hose to make sure. In fact, you never know when it's going to work again, so I'll get my hose set up. I'll take my oscilloscope out of the way and I'll show you exactly what I'm talking about. Okay, so as you can see, I've just connected a kind of hose. It's a kind of garden hose. It fits the right diameter there, and I've just kind of put cable ties around it. So I'm going to start the car. I did have a bucket under it previously. I know there's nothing going to come out here, so there's no bucket. Just wanted to show it just to prove the fault. So again, another crank. 1, 2, 3, 4, 5. Off. And you see, not a drop. Nothing came out. Bone dry. So this pump is drawing 14 amps, trying its best, but there's nothing coming out of here. So we know the fault doesn't lie elsewhere, it's inside here. And if you look on ELSA, there is a inbuilt fuel filter, so I'm not sure if it's collapsed or something's happened inside, but the fuel pump's bad. So yep, we'll get a fuel pump for it, and I'll update you in part 2.